Hello, my name is Elin. Thank you for coming. I'm working as an Android developer at Spotify in one of our platform and infrastructure teams here in Stockholm. And I'm here today to talk about modularization. So before I get started, how many of you have worked with a modularization project at all? OK, a few of you, cool. So modularization is the process of taking a big thing and turning it into many smaller things. Within software, that generally means taking files, putting them somewhere else, and still have it compile the same way it did before. Now, when you think about it that way, how hard can it be? It doesn't sound too hard. But yeah, a few of you have tried it out, so you might probably know that it can be very hard. So this is the TLDR of this talk. It can be very hard to modularize. But I'm going to keep talking about it a bit more because it's complicated. So modularization has been an extremely hot topic within Android development and Android land for the last, I'd say, 2-3 years. How many of you have worked or are working with Android development? Okay, a few of you. Keep your hand up if you think it's fast. Yeah, so there's a thing within Android that's called build times that is the worst thing about being an Android developer, where even if you were to install Android Studio and try to run a new app and run it in an emulator for the first time, you'd notice that it does take a few minutes to compile and run. And that's just a thing with Android. There's many complicated reasons to why build times are slow. But that's one of the reasons why modularization is such a big topic, because modularization is a process that can lead to lower build times. That's not actually something that I'm going to talk that much about today. I'll also not talk that much about Java modularization, like the module system in Java, because on Android, we barely have Java 8. Like, we can have lambdas, we don't have streams. So unfortunately, I don't know anything about Java modules. From what I hear, they're great. But modularization in Android, that's great old modularization. But again, that's not stuff that I'm necessarily going to be talking about, or details of how to set up modules and like the technical details of it all, because there's plenty of other talks and topics covering that. What I will be talking about instead is the Spotify modularization journey. And what I'm hoping that you can take away from this is lessons and learnings that we learned modularizing on a very big scale, because we had a very big code base and we're a very big team. So I'm going to start out with the why of why we started modularizing and why we did it at Spotify. And to understand that, you have to know some of the history about Android development and mobile development at Spotify. So it started out in 2009. We hired our first mobile developers, and they built this music streaming app and shipped it to people, and people used it and liked it. So Spotify has grown quite a lot over the years since then. About 5 years ago, we had about 10 or 15 Android developers. We've been growing a lot since then as well. We've been growing the amount of developers, the amount of teams, the amount of features in the app. Today, we are over 100 Android developers. We're spread over 50 teams. We are operating in Stockholm, Gothenburg, London, Boston, and New York. So we've been growing, our code base has been growing. And one thing we were seeing is that the growth of our code base was mainly growth of the main module in the code base, which is where we put all the code. And with the growth of that module was growth of the compilation time of that module. So we were becoming quite slow, and it was quite frustrating to work, which was sad because we like growing our features and we like building new cool stuff to ship to our users. So what we were seeing is this trend where everything was just growing and growing, and we knew how that would continue, so we knew we had to do something about it. And it was in the beginning of 2017 where we just sat down and decided, OK, let's do this. But then came the question of how do you actually do this? So yeah, over 100 developers, huge code base. Where do you get started? How do you coordinate an effort like this? We started by putting together a core team. They were 4 or 5 people, and they were tasked with figure out how to do this modularization and also prove that it's worth actually spending time on this modularization process. And they set up a single goal, which to get one feature outside of this monolith module and have it compile. And we also put in as a side goal to be able to run the unit tests for this in less than 5 seconds. And to preface that, unit tests in that module, running a single unit test would take about 3 to 4 minutes on a good day. If you ran the entire suite of unit tests in the module, that generally took 6 to 7 minutes on a good computer. So that's the kind of build times we're dealing with here. So yeah, put up this first goal, this first feature. And the first thing they did was to come up with a module structure. So we knew, because we had a big code base, we'd end up with a lot of modules. So we gave some upfront thought to how we would structure them. And the way we were seeing this is, we have the app, and we wanted to turn it into a ton of smaller modules. And how we were seeing it was that the app module, which is the main module, that was the big thing that knew about everything and had all of the dependencies to everything, but we wanted to pull things out of it to create standalone isolated modules. And we categorized them into feature modules, common modules, and library modules. And then we took stuff and put them within these. So features, those are our end-user facing features. So you have the search page and the home page, a library. Features are generally quite complex and have a lot of dependencies because there's a lot of business logic that goes into them. So we didn't want feature modules to depend on other feature modules. Instead, if you want to have code that can be dependent on by a bunch of other code, you either put it in the common modules or the library modules. And the distinction there is, so at Spotify, we do have a few different apps, not just like the music app. For instance, we also have an artist app called Spotify for Artists. And we want to share code within the apps, but also between the apps. But if you share code between the apps, it's important that the code doesn't have like business logic and stuff that is specific to the app itself. So then you share stuff in the library modules. And those are things that most apps require. So you have basic stuff like doing HTTP, doing dependency injection. A lot of the library modules were more third-party or like wrappers around third-party dependencies. And some others are frameworks that we have open sourced and it can be used by anyone. But then code that's common to our apps, for instance, we have Connect features. We have a Connect API that's used by a bunch of features in our app. So for that, we have that in the common modules. And then features can depend on those, but no libraries can depend on it. So within this graphics here, nothing can depend on anything in the layer below. We have some libraries that depend on other libraries and some common modules that depend on other common modules. But as long as there's no circular dependencies, you're sort of fine. So that was the module structure. And then the next step was to start creating some modules. And again, here we put in some sort of groundwork of making it as simple as humanly possible to create a new module, because we would be spending a lot of months just creating new modules. I also spent some time figuring out dependency management, because dependency hell is a very real thing, which is basically if you have dependency on different things, and then some modules depend on one version of the third-party dependency, and then other modules depend on some other version, and that can just blow up in your face. So for us, we put up a single central place where we defined all the third-party dependencies that we had and a single version for them so that we wouldn't run into those types of problems. And then the third step is just to put stuff into the modules. So yeah, with this first feature, obviously we didn't want to just put the feature and everything that the feature depended on in the same module, because we knew that we had other features to move out as well. So we wanted to isolate the individual's APIs and frameworks so that they could also be used by other modules in the future. When you put stuff into modules, the first thing you need to do is analyze the dependencies. And for this, you think of all the different things that you have, and you pick one thing that you want to move out. So for us, it was this first feature, which was a quite small and isolated feature, seemingly isolated feature. And then we took a look at, OK, what are the dependencies? What are the other APIs and stuff that this piece of code is using? And then you find some stuff, and then the next step is to look at those and see, okay, for these things, what kind of dependencies do they have? And what kind of dependencies do those dependencies have, et cetera, et cetera. And then the next step, when you have this idea of these are like the node modules that has no dependencies on anything else, then you move those out, and then you tackle the next layer and the next layer, et cetera. So when you have this idea of what you need to move, then you start breaking dependencies and moving these things out. And now breaking dependencies, that is generally like breaking the dependencies to other things within the main app module. Because since you're moving things out and you want to depend on those things, those also need to be moved out. And now breaking dependencies, that's where it gets tricky. So some dependencies are quite easy to just break. Like for instance, we found a few classes that had very hairy dependencies, but it turns out that that dependency only existed because they referenced it in a comment, like a Java doc comment. So it wasn't actually a dependency. And then in other ways, we had, for instance, we do a lot of A/B testing at Spotify, so we have this flags object that we send around, and that's the thing that we check whether or not a feature flag is on or off. And that has led to flags being sort of passed around basically everywhere. So a lot of things depends on flags. But actually, they don't depend on flags. They depend on, the Boolean that they're checking at the end. So instead of sending the flags object and having everything depend on flags, you can just send in a Boolean instead of should this thing be on or off. So those are the easier dependencies to break. And if you manage to break those, then you can be a happy developer, and you break the dependency, and you move the thing, and then you're done. But that doesn't always happen. Actually, it almost never happens. Dependencies are generally a lot hairier than that. And when you hit a dead end with a dependency that's seemingly just impossible to break, then you try again later, with the emphasis on the later. So what worked for us was a very iterative approach of moving anything that's possible to move without further work, and then seeing, okay, is there anything else that we can move now once we move the first batch? And then there's a little bit more, and then a little bit more, and then you hit a dead end, and then you put that on the backlog, and then you find something else to modularize instead. And then basically that's what you keep doing. You just move stuff, and then move more stuff, and then move more stuff until you're happy with the size of the monolith. So the first time we tried this, and okay, we sat down, we had the module, and now we pulled something out, and it didn't go that much to plan. Turns out it's difficult with this stuff. So yeah, especially the first time you start pulling on a string, and you're like, this class I can move, and then it turns out that that has 5 dependencies, and then you try to move all of those classes, and then those have 20 dependencies, and you move those, and then all of a sudden you've just moved the entire module to another place, but it's still the same size. So then, you went back to the drawing board, tried to figure out, okay, how do we break these dependencies? Do we see some patterns here? What did this compilation error means? We're getting it over and over. And then by the 10th attempt, we did manage to get something out. It wasn't perfect. API boundaries wasn't the greatest, but it was something. And then again, you keep doing this, and then you get really good at it. So, by the 100th time, we saw all of the patterns, and we knew exactly what all of the compilation error meant. And I mean, we weren't this good. I don't understand how this is a thing, but anyway. The lesson is that it takes time. Modularization will take time. It's a huge effort. You have to be patient with it. So going back to this goal, getting this first feature outside of the monolith, we did that. It took us 2 months. We learned a lot along the way. And like I said, we had this goal of compiling this within 5 seconds. And we didn't know if that was a stretch goal, if we needed to do additional stuff to make it work. But once we had it out, we ran the tests. It ran in 4 seconds. And we didn't have to do anything, which was woohoo! And that was a great motivator to keep going. So at this point, we grew the team. This is when I joined the effort. Now we were about 9 or 10 people. And we set the next goal, which was to get all of the frameworks and APIs that all the other features needed to move that outside of the monolith. Because like I said, I work on a platform and infrastructure team, so we own all of these like frameworks and APIs. So it was sort of on us to unblock the feature developers. Because obviously, the ultimate goal of modularization for us was to have pretty much everything outside of the monolith, which meant that feature developers would have to be able to modularize. So we were keeping metrics all throughout this while. So this red line is how many lines of code we have in the repository overall. The blue line is how many lines of that was in the monolith big module. And then the yellow is just the difference. So you can tell, I mean, first of all, you can tell the growth that was scaring us. And yeah, this is like build times is just growing alongside here. And then you can tell that it was about March or April 2017 when we started working on modularization, because you can see it stopped growing. And yeah, it stopped. It didn't decrease in size, even though we were working. So this is about maybe 6 or 7 months of hard work for us, trying to pull any piece of code that we can find just out of the app to make it as small as possible. And nothing happened. We started wondering, OK, so why is this happening? Oh, right, yeah, feature developers, right. They're building new features. They're adding stuff to this thing that we're trying to make smaller. So we're in the sinking ship with buckets, and then they're just going around with drills and just adding more holes to the sinking ship. And it's like, OK, we need to do something here. Like, obviously, we need to move all of these APIs and stuff, but something's got to give. So we went to them and we asked, OK, so can you put anything outside of the main app? Like, can we just not put any more code in it? And they said, no. Like, we have to put it there because your APIs are not out. Like, there's nothing we can do as feature developers to aid your process. And we thought that that's not technically true. Because even though they can't physically put their code in another module, given that they're writing new code, maybe they can write it as if it's in a module. Because if they write it as if it's in a module, it's going to be so much easier to just put it in the module afterwards. Basically, don't add the complex dependencies that makes it difficult to modularize. So that sort of shifted our focus a little bit. And we started thinking about best practices and getting the feature developers to follow good practices. And now, these aren't any new or groundbreaking best practices that we found, but I'm going to walk through a few of them that really works specifically for modularization. And the first thing is to just deprecate and remove code, because it's a lot easier to just delete code than moving it, it turns out. So for us, this meant we had a few frameworks and APIs that we were thinking, should we modularize these? Or should we just get rid of them because they're really bad? So let's just write something that's new and nice in a module to begin with, and then we don't have to deal with modularizing this old stuff. And the next thing that we did was to just stop re-implementing the wheel, which meant for us just removing a bunch of code that was doing the exact same stuff as a bunch of other code. So in a lot of features, they were doing the same things. There was copy-pasted code. So instead of just moving all of that code and have it live elsewhere, we just abstracted APIs, and then the feature modules the features themselves got smaller because there's less code in them, and that makes it a lot easier to move it because there's not as much code to move. The next was to stop leaking implementation details. And now, if you have a very leaky API or a leaky implementation of an API, that means that you're forcing the consumers of your API to know about implementation details within the implementation itself. And for us, one of these things was this flags object that we kept passing around. And instead of having that flags object put around, if you could just have a Boolean instead, then you're not forcing the consumer of your API to know about flags. But then, in addition to that as well, is dependency injection. So rather than forcing the consumers of your APIs to give you your dependencies, use a dependency injection framework instead, so that you can get your dependencies without forcing that onto your API consumers. And the next one was structure and code organization and consistency. So I think in general we talk a lot as technical engineers about patterns and structures and what's the best structure, what's the best way of structuring your code. What we noticed was a consistent structure beats like any level of like this structure is better than this structure. So for us, we just picked MVP and said to all of the feature developers that you should just like, this is how you structure your code. And all of you should structure it the same way. Like, as long as you have some separations of concerns between different pieces of like business logic and UI logic, and it's testable and it's nice, the implementation details of how exactly you choose to structure your code is so less important if you don't do it consistently across your features. Because if you do it consistently, that's when you can start seeing patterns. That's when you can start seeing that, oh, 5 of our features are doing the exact same thing. Or we're missing these APIs, or we're having super leaky bugs because everyone's following this pattern. But now we know that all of them is following the same pattern, so let's just improve the pattern instead. And then I'm going to briefly mention solid principles. So solid principles, I hope you're aware of them. And if you're not, I'm not going to talk about them, but you should look them up. They're great. We have like TLDRs for them. But the one I want to talk about most is the last one, which is the dependency inversion principle. Our TLDR of it is depend on abstractions, not on implementations. And the dependency inversion principle proved extremely useful specifically for modularization, and specifically for really hairy dependencies where you're trying to move a thing that just happens to use like just the biggest source of spaghetti code that you can imagine in your app. So imagine a class that just happens to know about every single thing that's going on in your entire code base, and you're trying to move something that's using that. And you can tell with sources like spaghetti like that, you will probably never be able to move them properly. But you still want to move your thing. So what you can do then is you can, say you're calling like getFoo method. If you put that getFoo method in an interface, and then you can depend on the interface and call the interface, you can put that interface in a module, and then you're calling that method on the interface. And then the inversion bit there, the dependency inversion, is that you bind the implementation, which in this case can be this big like spaghetti mess. And for us, we use Stagger 2 for dependency inversion. And for us, we can bind the implementation, which is the spaghetti code, with the interface. So in your code, you're injecting the interface. Under the hood, you're getting the spaghetti code, but you don't have a dependency on it. And yeah, super useful when it comes to modularization. So does this work then? Does going to developers and saying, hey, just like fix your code, write it this way instead, does that work? So I'm going to go back to the graph. So we left off when the blue line was flatlining, and nothing really happened. You can actually tell after that that it grew a little bit more. That was extra frustrating after like 7 months of work, and that was also when we were trying to tell feature developers to, like, hey, can't you like prioritize modularization in your next sprints? And they were just like, no, we're just going to add more instead. But then after that, you can see that there's a drop. And what happened there was we stopped working on modularization. In the modularization team, we gave up and stopped working on modularization because we'd moved everything. Didn't really have anything left. So then feature developers, when we asked them very nicely, they actually started doing it. And you can see that you can kind of tell that it shrunk quite rapidly in the beginning. And those were mainly these new features that were written according to these best practices, and they were just easy to move. Like, remember, this first feature took us 2 months to modularize. These features generally took 2 or 3 days to move. And the team, they did it, they moved it, they noticed that their build times got way better, and their testing times got way better, and a lot of people just started writing a lot more tests on, which meant that we got better code quality, and just everything went great. So then today, we're about 200,000 lines of code in our main monolith now. You can see it started to trickle out a bit. And that's because now features developers have sort of run out of stuff to modularize as well. Now the only thing that we have left is the big pieces of spaghetti code that we use dependency inversion to avoid modularizing. Now those are left. So now we're going to have to go back and deal with those again. But hopefully it's going to be better because less features are in there. So yeah, now we're back to when we were in 2015. So that's nice. I mean, it's something. So given that the main reason for us doing this was build times, have that improved at all? And it has. It definitely has. We have about, I guess it must be about 700 modules at this point. And now build times for those modules is way better. It's way down. So we use Gradle. That's Gradle is the build system for Android, if you're not like Facebook or Google. Gradle is great these days when it comes to modularized codebases. So, the compilation time, it can all be parallelized, and we can use stuff like remote caches and local caches to cache the build artifacts. So if you're doing a change in a module, you're only recompiling that module and possibly other modules that depends on it. And then the rest we just fetch from the cache. So overall, our day-to-day is much better. So going from 6 to 7 minutes to run tests and assemble the app in modules, it's generally between 5 and 30 seconds. It's faster when the caches are hot. And assembling the app still takes 2-3 minutes, because Android needs to do annotation processing and assembling and all types of weird stuff. The build times are better. But there's also a few lessons outside of just build times that I think none of us really thought of going into modularization that we would gain from it. So I want to talk about those. I mean, the first thing is just having patience and having focus. So one thing, doing modularization, you're going through a lot of code. And a lot of that code is going to be kind of old and gross code, where it's really tempting to just you open a class, and it's I can just rewrite this a little bit before I move it out. It's a trap, don't do it. Because if you start doing that, you will never, ever get around to actually moving it. And one thing to think about is that you can use the opportunity to just write down all the things you want to fix, and then fix it once it's in the module, because build times are faster then. So it's a lot better to do it afterwards and not while you're doing it. And the next thing, so it's hard to see the forest for all the trees. So imagine standing in a vast forest. There's just millions of trees. It's really difficult to think about what does this individual tree look like, and is it healthy in comparison to all of the other trees? Because you're just overwhelmed with it. That's a thing of our brain. We're not able to comprehend things when they're not isolated. And that's the same with code. So it's really hard to think about your individual API or your individual feature when it's in this just blob of stuff. So in that way, modularization is really a tool. It's a tool to allow you to think about your APIs and your code in isolation, which is a great thing. And it's something you don't really think about will happen until it does. It's also a chance to get to know your code base. It's a chance to realize what are all of the APIs that we're doing and what kind of stuff is going on in the feature modules. What are people implementing over and over again? What are APIs that we should have and have a single API and maintain that for everyone instead of everyone just doing it over and over and over? And it's also a chance to tackle tech debt. Because, yeah, I talked a lot about best practices, and that's because you kind of have to follow best practices to be able to have code in isolation. I mean, don't get me wrong, you can definitely still have really shit code in modules, and way too many dependencies, but it's a lot easier to not have them. And when it comes to it as well, adding new tech debt and adding new broken stuff, it's a lot easier to spot that when you're in isolation as well. So imagine you have a change that's adding 10 seconds of compilation time. If you're adding that to something that already takes 5 minutes to compile, you won't notice it. If you're adding it to something that takes 5 seconds to compile, you just triple your build times and you're going to notice. And that's the same thing if you have a change that's adding 60 dependencies, but it's only doing one thing. That's suspicious. And also, if you're introducing something that goes against the patterns and the consistency of how modules do things, that's a lot easier to spot as well. So Yelp wrote an article their modularization process a while back, and they start out with this quote. So they say single modules are easier to deal with because there's no complex dependency graphs to account for. So this is in the context of why you might not want to modularize and why you might think that it's not worth the effort. And I read this and I thought it was really interesting. Because to me, so I've revised this a bit, because to me, single modules appear to be easier to deal with. Because there's no complex dependency graphs, expressed in like Gradle files or module.info files where you have to explicitly say all the dependencies that you have between different things. But just because you don't mention that in a manifest somewhere, it doesn't mean that the dependency doesn't exist. You still have complex dependencies between your code and you have spaghetti code, and that's why it's difficult to modularize. And by having it in a single module, you're just ignoring it, basically. So yeah, I want to bring it back to this first question. So modularization, how hard can it be? It can be very hard, as we've been talking about. But there's also the aspect of software development. How hard can that be? And that can also be very hard, it turns out. You can make it easy by following good practices, by being intentional and aware of your API design, of putting effort into high quality and that kind of stuff. Or you can make it hard by introducing tons of dependencies and just intertwining all of your code with all the other pieces of code you're writing. And then software development can be very, very hard. But it can also be oddly satisfying. And now this was the tagline of our whole modularization effort. And it was something that, this is the channel description for our Slack channel where we do modularization support. And it was like our internal motivator a little bit. So modularization is not a fun thing to do. It's extremely tedious. It takes a lot of work. It's manual. You can't really automate it at all. And in general, it's not fun. You don't want to do it. However, when you come to the end of the line here, so for us, there was a few dependencies that we were struggling with for months. But we kept to the process and we kept to this okay, let's just move everything and not think about this big pending doom of this super difficult dependency that we have to deal with at some point. But then when we got there was no other dependencies because we'd already fixed them. So this big thing that took us months, after those months, we could just move it and we were done with it. And we could run the test and it was super fast and it was blazing and it was so, so satisfying. So highly recommend, even though it's a terrible process, the rewards are so worth it. So with that, I want to thank you for listening. Yeah. If there's anyone who have any questions, we can take them here, or you can just come down to the stage afterwards and we can talk then.
I'm Jody Ramper, and we are from a payments finance company. Now we have a similar issue about the refactoring or structuring our payment service code. Because considering from technical side, even we make sure that the code has no problem. But considering lots of transactions per day, it's may bring bugs, and which is super critical and scary for the company business. So I was just questioning how's the simplified testing between the technical side and also testing to make sure how the code is no bugs to the real user, because you have lots of millions of users also. How do you do this?
Yeah, so the question was how do we test and how do we make sure we don't break things as we're modularizing? Yeah. So I mean, we have tons of just unit tests, integration tests, end-to-end tests, and yeah, we just kept running them, and we managed to just not break them. I mean, we broke some, but the thing with modularization is you're not changing the logic that much. You're just moving it around. And with the case of dependency inversion, that's the same thing. Like, you might add more code in like APIs and interfaces in between classes, but you're not actually changing the business logic at all. So it's not that scary when it comes to like, oh, we're going to break, the experiments for our end users because we're not changing anything. So when it would come to that, I mean, it's like other types of refactorings that you need to do for those things. But we try to cover everything with tests and hope it goes well. But yeah, I mean, the main stuff that we broke during this process was we accidentally broke, master because we happened to merge something, and it turns out a resource wasn't found, and for whatever reason, CI didn't catch that, and we merged it. But I think we broke master like 3 times during this process, which was quite good, if I may say so myself. Like, that was like in the first few weeks, and then it was just fine. Any other questions? No? Cool. Okay, thank you.